any colors.
Any colors? What colors?
It needs 3 colors.
3 colors?
3 different ones.
And you're asking me for stuff.
No, he is. I have it done. You were just asking me for That's because That's because I needed the same colors as Charlotte.
Oh, frick. I hope you like him.
It don't matter. That's I have to do And it'll go over the top. I thought it was a funny joke.
It was a funny joke, but
What order should I do this?
I'm called for.
It was clearly
I'll make blue is for buffer. This is the one that's maxed out.
Why do you think it's me? I
You ever need a
don't
pencil?
want it.
Let me know. Evidently
I have a calculator.
Hey, so I got you.
Okay, so let's chit chat.
I got a new one.
What? She's being the problem, and
I have a good solution.
she's being really mean to me
Through
today.
mechanical business.
Body
The
check
straight
to
lead.
take
It ran into me.
No,
And then Morgan didn't even move out the way.
It's a trend. Never get a bad
And
grade on
Mac
test. I
body
just snapped
slams me.
I don't know what you're
I one time snapped a pencil in the test and I didn't know.
Obviously, Morgan's problem.
And
I
I
think so.
found it really funny, and it wasn't funny.
Actually, the time I broke it in this test, I was sitting there and I was like reading the test like
Okay,
this, and I had it in one.
so. Hush my chemistry children. So, here's roughly what your pH graph should look like. We're gonna do all 3 of them, right? Roughly. Okay?
Really rough. Very rough. Pretty rough.
Like rough and rough?
They should at least have 3 distinct starting points.
Yes, they do. We have the.
Okay.
Okay,
Okay, I'm gonna say.
where
close
it
enough.
gets into the equivalence point and where it levels off, that can get a little sketchy. So, make sure I know which one is which. Color code it, label them, do something, okay? Ideally, especially once you get into the spaghetti section where they all overlap, I want to know which one is which. Now, what you have to do with the first titration, when it was just straight acetic acid and sodium hydroxide, go to that curve and over here on page, on the second page of, I think it's on the blue sheet, okay? You, down there at the bottom, on the first graph, the non-buffered one, graphically determine the pKa and then use that value to determine the experimental value of the Ka acetic acid, hint, draw 3 lines. So on this, you only do it on the first one, not all 3.
Where does it select
I don't see. You lie. I found the PKAs because you told us to do that yesterday.
I also
Really?
did it. I went for one of them because it didn't say anything.
Okay, all right, never mind.
You lie.
No, I changed it, but I didn't run, that is the version that I ran off for you guys. Okay, so don't worry about it.
Yay.
Okay, don't worry about it. But here's what you have to be able to do, okay? God, I can't believe I didn't do that. Okay, so here's what you should be able to do. You should be able to take that graph, God, that annoys me, and come in here and go, okay, here's the equivalence point, there's half the equivalence point, there's your pH, which equals your pKa. I promise you, on the test, not so much the quiz tomorrow, but on the test over this, yes, there's a quiz tomorrow.
I have so many 4-letter words.
The vision.
Huh?
Me too.
really good with numbers.
That's why I'm telling you now.
Have you went on a vision quest and decided when the test is yet?
Cohen, are you done with colors? Okay. I feel like your name
No, it's going to be after parent teacher conference.
color. Are you done with colors?
Hey,
After parent
Are you done with colors?
Now,
Yes? Yeah, you bring them to me.
okay, so then, let's talk about that question where it says, because what's on there is that said, explain the differences in the 3 graphs, okay? And here's what I'm looking for on that. that question number 20, which I changed and it didn't run off for you guys. So annoying. Is that understand fundamentally, when you talk about pH, what are you measuring?
Concentration H plus.
Okay, your pH is the negative log of your hydronium ion concentrations, okay? Notice that is not hydroxide ions, that isn't anions, it isn't anything else other than that. But if you have that, then you can figure out everything else. So, when you look at this differences, understand that the only way you can have a different pH value, especially as these pH values go up. And here's the dichotomy. The higher your pH is, actually what happens to the concentration of your hydronium ions?
It goes down.
It goes down, okay? Now, here's the story. When you look at what's going to happen in terms of Ka, and this is going to play out even today when we talk about KSP and QSP. Mother Nature wants that Ka value, okay? Because that's when Mother Nature is most stable. So here's the trend that I want you to see. When you compare the non-buffered solution, where both of those are just X, okay? Non-buffered solution, old school, you're going to ionize into hydronium ions and anions. This is going to start off at some molarity, that's going to be 0, you go minus X, plus X, all that jazz, okay? Everything is going to start off at 0 because you want to generate this Ka value. So if you look at what happens, what you guys did, you guys initially added just a tiny bit of sodium acetate, okay? 0.0373, okay? So right away, that anion concentration shifted from being 0 to something else, okay? It's a number. But what you have to understand is that Mother Nature still wants that same Ka value. So mathematically, as that anion concentration goes up, the concentration of your hydronium ions to create the same Ka value has to go down. Okay? That's the trade-off.
Yes, it is.
This stays the same. So as and you remember this even when you get into KSP and QSP today. As one value goes up, the other one's going to go down because you still want the same Ka value. Okay? Now, indicate on the two buffered graphs the region where maximum buffering occurs. Don't worry about that, but I'm going to show you where this is going to happen. Okay? So don't worry about that. On number 20, do not worry about that part. But let me show you where it's going to happen. So if you look at your pKa for this acid, because it's acetic acid, which is 4.74, typically maximum buffering occurs 1 pH on either side of that. So it's generally like between 3.74 and 5.74. That's where maximum buffering is going to occur, because that's when you have your highest concentration of your anions and the acid to react with both. Okay? So don't worry about that part of the labeling, but just know that's where maximum buffering is going to take place. Okay? Don't worry about it. I'm never going to ask you that, but just know, hey, maximum buffering occurs obviously before you hit the equivalence point. And it's 1 pH point on either side of the Ka value. Okay. So your answer to number 19, okay, should start with a 9. Okay? Your answer to number 17 should be around 5. Okay? Now, I know some of you haven't had a chance to actually do experiment 11 and 12. So let's go over there right quick and get that part done. So, Kevin, can you stop you on the camera? So let's go over there, get that measured out, make that